May the peace, blessings, and mercy of God be upon you. Hello everyone in Junior 4. I am Mrs. Yasmin Yasser. I am going to be your math teacher for our lesson now. We studied in the previous lessons how can we make a comparison between two or more numbers. In today's lesson, we are going to study the difference between estimation and rounding rules. The first topic in this lesson is talking about front-end estimation. We use this method to make a very fast answer, not be accurate. And to round any number, we put my eyes on the left on the highest place value and replace the digits in the last place with zeros. Let's take a given example. Estimate the following numbers. The first one. The first number is written in standard form. So we put my eyes on the left on the highest place. Then we find the digit 1. So we write the digit 1 as it is and replace the digit in the last place with zeros. Let's count with me. 1, 2, 3, 4, 5, 6, 7, 8. So we put 8 zeros. So this number approximately equals 100 million. The second number is written in expanded form. When we have numbers as written in expanded form, write the place value for each digit. 30 million. So the digit 3 is in the 10 millions place. 5,000. So the digit 5 is in the thousand place. 400. So the digit 4 is in the hundred place. 2. So the digit 2 is in the ones place. We search the digit in the highest place. We found the digit 3 is in the 10 millions place. So this number approximately equals 30 millions. The third number is written in word form. When we have number as written in the word form, circle the name of each family. So we make a circle on millions. Then we make a circle on thousand. And we search the digit in the highest place. We found the digit 2 is in the millions place. So this number approximately equals 2 millions. The fourth number is written in expanded notation form. When we have numbers as written in expanded notation form, write the place value for each digit. The digit 3 multiplied by 10,000. So the digit 3 is in the 10,000 place. And the digit 4 multiplied by 100. So the digit 4 is in the 100 place. And the digit 6 multiplied by 1 milliard. So the digit 6 is in the billions place or milliard place. Now we search the digit in the highest place. We found the digit 6 is in the billions place. So this number approximately equals 6 milliard or 6 billions. The second topic in this lesson is talking about rounding rules. We have two strategies to round any number. The first strategy is called midpoint strategy. Let we have this straight line and we have 3 points on this line. Lower point and midpoint and upper point. How can we round any number by using this strategy? Let's take a given example. Round the following number by using midpoint strategy. The first number. Round the first number to the nearest thousand. So we're looking for the digit in the thousand place. Where is the digit in the thousand place? The digit 7. So to write the lower point, we put the digit 7 as it is. And we replace digits in the last place with how many zeros? 1, 2, 3. So we put 3 zeros. Now, to write the upper point, we add 1 to the digit 7. It will be 8. And replace digits in the last place with 3 zeros. It will be 8,000. To write the midpoint, we write the digit 7 as it is. And replace the digit 0 on the highest place with 5. Then we complete by the same numbers of zeros, 2 zeros. Now, these numbers be above the midpoint or below the midpoint. 7,531 is greater than 7,500. So these numbers be above the midpoint. So this numbers is closer to the upper point. So these numbers approximately equals 8,000. Now, the second number. We need to round this number to the nearest 10,000. So we're looking for the digit in the 10,000 place. Where is the digit in the 10,000 place? The digit 4. So we underline the digit 4 and all digits in the next higher place. Now, to write the lower point, we put 24 as it is. Then we replace digits in the last place with how many zeros? 1, 2, 3, 4. So we put 4 zeros. Now, to write the upper point, we add 1 to 24. It will be 25. So we write 25. And we replace the digits in the last place with how many zeros? 4. 1, 2, 3, and 4. Now, to write the midpoint, we put 24 as it is and replace 0 in the highest place with 5. Then we complete by the same numbers of 0. So we put 3 zeros. Now, these numbers be above the midpoint or below the midpoint. 241,371 is smaller than the midpoint. So we put these numbers, we put x below the midpoint. This numbers is closer to the lower point. So this numbers approximately equals 240,000. 240,000. The third one, we need to round this number to the nearest 10 millions. We're looking for the digit in the 10 millions place. Where is the digit in the 10 millions place? The digit 7. So we underline the digit 7 and all digits in the next higher place. Now, we need to write the lower point. We put 47 as it is. And we replace digits in the last place with zeros. How many zeros? 1, 2, 3, 4, 5, 6, and 7. We put 7 zeros. 1, 2, 3, 4, 5, 6, and 7. To write the upper point, we add 1 to 47. It will be 48. And replace digits in the last place with 7 zeros. 1, 2, 3, 4, 5, 6, 7. Now we need to write the midpoint. So we put 47 as it is. Then we replace 0 on the highest place with 5. Then we complete by the same numbers of zeros. 1, 2, 3, 4, 5, 6. Now, this numbers is above the midpoint or below the midpoint. This number is below the midpoint because 471,253,321 is smaller than 475 millions. So this number is closer to the lower point. So this number approximately equals 470 millions. The second strategy is called place value strategy. We have two kinds of numbers, happy or rich number and sad or poor numbers. The happy numbers are given by 5 and 6 and 7 and 8 and 9. And sad or poor number are given by 0 and 1 and 2 and 3 and 4. The happy numbers add 1 to the digit in the next higher place, but sad or poor number not add anything to the digit in the next higher place. To round any number by using this strategy, let's take a given example. Round the following number by using place value strategy. The first one, we need to round this number to the nearest thousand. So we're looking for the digit in the thousand place, which is 9. We underline it. And we're looking at the digit in the next door, which is 6. Now, 6 is happy number or sad number? 6 is happy numbers. So, the digit 6, add 1 to the digit 9. So, we cross out 9 and write 10. Then, we replace the digits in the last place with how many zeros? Let's count with me. 1, 2, and 3. 1, 2, 3. So, these numbers approximately equal 10,000. The second one, we need to round this number to the nearest 10,000. So, we're looking for the digit in the 10,000 place, which is 1. It is ones, it is tens, and it is 100. Now, we underline the digit 1 and all digits in the next higher place. Now, we're looking at the digit in the next door, which is 9. 9 is happy number or sad number? 9 is happy numbers. So, the digit 9. Add 1 to the digit 1. So, we cross out 1 and write 2. And keep the digits in the next higher place as it is. So, we write 3 and we write 2. And we replace the digits in the last place with how many zeros? Let's count with me. 1, 2, 3, and 4. 1, 2, 3, 4. So, this numbers approximately equals 2,320,000 to the nearest 10,000. The third one, we need to round this number to the nearest 100,000. So, we're looking for the digit in the 100,000 place. Where is the digit? The digit 1. So, we underline the digit 1 and all digits in the next higher place. Now, we looking at the digit in the next door, which is 0. 0 is sad numbers. So, the digit 0 not add anything to the digit 1. So, we write the digit 1 as it is and all digits in the next higher place. Now, we replace the digits in the last place with how many zeros? Let's count with me. 1, 2, 3, 4, and 5. So this number approximately equals 4,100,000 to the nearest 100,000. The fourth one, we need to round this number to the nearest millions. So we're looking for the digit in the millions place, which is 4. It is million and it is 10 million. And all digits in the next higher place underline it. And we're looking at the digit in the next door, which is 8. 8 as happy numbers. So the digit 8, add 1 to the digit 4. So we cross out 4 and write 5. And write any digit in the next higher place. So we write 1. Then we replace the digits in the last place with how many zeros? Let's count with me. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this numbers approximately equals 15 millions to the nearest million. The fifth one, we need to round this number to the nearest milliard. We're looking for the digit in the milliard place, which is 1. We underline it. And we're looking at the digit in the next door, which is 7. 7 is happy numbers. So the digit 7. Add 1 to the digit 2. We cross out 2 and write 3. Then we replace the digits in the last place with zeros. How many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we put 9 zeros. It is 3, it is 6, and it is 9. Let's take another example. Estimate by using rounding to check the reasonableness of the answer. To check the reasonableness of the answer, we have 2 steps. The first step, we add, then we round. And the second step, we round, then we add. If they are same, the answer will be reasonable. And if they are different, the answer will be non-reasonable. The first one, we need to add 254 to 123. At the first, we must align the number with digits exactly above each other. We put 3 under 4 and we put 2 under 5 and we put 1 under 2. We start from the ones place. 4 plus 3. 4 plus 3 equals what? We put 4 in your mind and put 3 in your hand. After 4, 5, 6, 7. So it equals 7. Go to the tens place. 5 plus 2. Also we put 5 in your mind and put 2 in your hand. After 5, 6, 7. It will be 7. Go to the hundred place. 2 plus 1. After 2, 3. Then we need to round this sum to the nearest 100. So we're looking for the digit in the 100 place, which is 3. We underline it. And we're looking at the digit in the next door, which is 7. 7 is happy numbers. So the digit 7. Add 1 to the digit in the next higher place. So we cross out 3 and write 4 and write 2 zeros for the ones and the tens place. The second step, we round the 2 addend to the nearest 100. So we're looking for the digit in the 100 place, which is 1. And we're looking at the digit in the next door, which is 5. 5 is happy numbers. So the digit 5, add 1 to the digit 2. It will be 3. And hold ones and the tens place with 2 zeros. The second addend. Where is the digit in the hundred place? The digit 1. We underline it. And we looking at the digit in the next door, which is 2. 2 is sad numbers. So we put the digit 1 as it is and hold ones and the tens place with 2 zeros. Then we add 300 plus 100 equal 400. Now they are same, so the answer will be reasonable. The second one, we need to check the reasonableness of the sum of 15 and 49. We align the number with digits exactly above each other. And we start from the ones place. 5 plus 9. We put 9 in your mind and put 5 in your hand. After 9, 10, 11, 12, 13, 14. Can you write 14 at one place? No. So we write 4 in the ones place and carry up 1 to the next higher place. And then we add 1 plus 1 equals 2 and plus 4 equals 6. Then we round to the nearest tens. The digit in the tens place is 6. We underline it and we looking at the digit in the next door, which is 4. 4 is sad numbers. So we put the digit 6 as it is and hold the ones place with 0. Approximately equals 60. Second step, we round the 2 addend to the nearest tens. Where is the digit in the tens place? The digit 1. We underline it and we looking at the digit in the next door, which is 5. 5 is happy numbers. So the digit 5, add 1 to the digit 1. We cross out 1 and write 2 and hold the ones place with 1 0. And the second addend. Where is the digit in the tens place? The digit 4. And we looking at the digit in the next door, which is 9. 9 is happy numbers. So the digit 9. Add 1 to the digit 4. We cross out 4 and write 5. And hold the ones place with 1 zeros. Then we get the sum. 20 plus 50 equals 20. They are different. So the answer is non-reasonable. That's all we have for our lesson now. Thank you for all.